Welcome to the Analytics and Visualization stage. I'm here on the beautiful Swedish West Coast.
The West Coast, that sounds good. Thomas, do you mind introducing you to the audience here?
Hi, my name is Thomas Svahn and I just love data and analytics. I've been working in this field for about 20 years and I'm still in love with it. Especially visualization, which I think is a fantastic thing that you can really bring some insights into your data. And that is what we're going to talk about today. Today I'm leading the Swedish unit called Insights and Data for Capgemini, and I love my work.
Thanks, Thomas. This is going to be exciting. So my name is Robert Engels. I'm the CTO for IND in the Northern and Central Europe, and I also lead the Center of Excellence for AI in the Nordics and in the Netherlands. And today we're going to take you on a trip down data interpretation and data visualizations. Please bear with us. For centuries, humans have used data visualizations to convey messages to each other and discuss complex problems. All data visualizations heavily depend on interpretations of the underlying data. So while people are great in interpreting images, data visualizations are a great tool for reaching out to these people. But data in our world grows exponentially, and it is actually delivered faster and faster and faster and faster. Automation is of the essence. So how can we actually make sure that data is machine understandable, can be processed automatically, and really serves us in an understanding of what is going on? Currently, many organizations are looking to become data-powered enterprises. And that means they want their data to be interpreted more and more automatically and with greater accuracy. But how do you know you actually have all the data that you need to analyze your problem? It is a safe bet to say that with current automation, where it is in automotive, in life science, in finance, or whatever sector you want, it builds upon an incomplete view of the world around it. And even if you actually can get hold of much of the data that you need, how do you combine, merge, align this data, coming from various places within the organization and maybe even from partners, suppliers, or third-party data providers? Also here, data visualization can help out. Given a data ecosystem with various non-connected, non-integrated data sets, it is possible to build, for example, a graph-based virtual integration layer on top of that, where you can visualize relations and patterns you couldn't see from the data sources alone. And I would suggest that we have a little demo based on a backend built on Neo4j, which is actually presenting tomorrow, combined with the front-end visualization layer by Linkurious. And the demo combines the idea of virtually combining various data sources, produces human interpretable visualizations, but also comes with various algorithms for graph analytics to assist when networks of data grow. Let's have a quick look. In order to avoid that you probably miss some data points or information that you might have, you might as well visualize your data. And you can do that across different data sources. So what you see here is a little demonstrator based on a graph storage database with a very nice graph-based interface on top that shows you how different data sets can integrate. In this case, we have a little demo based on our good old Monty Python with Harry the Haggler, for example, as the central person. Harry the Haggler has 8 different facts known about him. There's a padlock telling me that I have access to all the data. I can inspect Harry the Haggler and then I'll see that there is like 2 properties, damage claims. There is a car registered on him. There is an HSBC bank account, an email, a social security number, an address, and a telephone number. Now we can expand by just clicking the notes, so you can see that Harry the Haggler had a variety of telephone calls back and forward with another telephone. There is property damages attached to him. If we expand those, you might see that both property damages have 2 parties involved, Tim the Enchanter and the King of Swamp Castle. We have the bank account. If we expand that, you see that there is transactions getting in and out. You can inspect those transactions with the transaction analysis tool here. You might be able to find out how much is going in and out, at which time points. And then you can actually have a further inspection of the telephone calls with the counterpart, which is in this case Mandy Cohen. And Mandy Cohen again has a link to the King of Swamp Castle through a company called Delta Analytics Limited. So there we have a circular relation from Harry the Haggler through telephone calls, through a woman, through a company related to the lawyer company that was involved in property damages. So we have one circle. Now the other one, the money, we expand that to Deadly Dirk. And if we look closely, we see that Deadly Dirk has a property claim with the same two involved, Tim the Enchanter and the King of Swamp Castle. So now we have a second loop here, and that already might make you very suspicious. You see that every color in this graph is actually a different data source, which is not physically integrated. So they're integrated on the level of this graph network to visualize. And now we can also actually try to find out what's going on with the three of them, and we expand, in this case, the email, and we see there is one email about a fund transfer where Deadly Dirk, Harry the Haggler and Mandy Cohen are involved, so they're all in this email. And then you have quite some evidence, and probably found the evidence to actually follow up on this fraud. Now, you see it's a graph, so you can do more things with it. You can find hidden patterns. So if you have a lot of data about transactions from many different sources in your bank, for example, an insurance company, you might want to integrate the banking and the insurance part and find hidden patterns. Maybe you can add some company structures, maybe you know who is related to who, or people living on the same addresses and so on. You can all add that, and then you can use graph analytics algorithms for analyzing the graph in more detail or finding interesting information automatically. For example, you can, if you click on Mandy Cohen, you can select the shortest path algorithm, which is quite a naive one, and search for Harry the Haggler, and you find the shortest path between Mandy and Harry the Haggler, which in this case goes through the telephone. But you can also do more complicated things with other algorithms. So there's a whole library of algorithms for graphs with different types of algorithms that use graph mathematics to calculate centrality, communities, pathfinding, and search. But you might also want to add your own machine learning algorithms. Now, this kind of functionality gives you an incredible powerful visualization of your data sets, and you as a human being can inspect this and find circular relations, but also certainly automatic graph analytics algorithms can help you and support you with that. So far for this demo, we go back. So that is definitely what I love about these demonstrators with graph technology, that you can actually link and hook up and connect all these different data sets together. And then you can use graph analytics on top of that to actually find out what is in your data.
Stop.
Thomas?
You're so enthusiastic, it's very hard to stop you. So, but I think the people are really interested in to see some more examples. Do you have some more examples for us?
Yes, sure, Thomas, of course. Okay, let's go to this process. We have 6 steps between that data originates and is received by the receiver. Let us have a look at these 6 steps. The first one is about what is not in your data foundation. Do you know what's not there? There is a lot of things that can go wrong with data. This is an example of people that actually want to avoid face detection. So they have found out how you can schmink and what you can put on your head actually to avoid that a camera can actually recognize your face. So this will not be in the data. This whole group will not be in your data. There is just a cluster of probably important data in your data set missing. Another one, this is not new, another one is really from the Second World War. Fake dummy tanks put in southern England just to make sure that the reporting and the visualizations that were done in Berlin were actually misleading, because these tanks were visible in areas where they didn't want to have an invasion or didn't do an invasion, but on the parts of the invasion when they were in Normandy, the tanks were hidden. So the reporting was very easily influenced by this. And influencing is also something that this guy tries to do. So this is actually code that would delete part of the database if it is executed by the license plate recognition system used by the motorway authorities. So you will also actually lose large parts of your data. So there's different ways in which you can really avoid data or delete data and spoof data. So adversarial attacks are very important to know about, and also have an idea about if this is something that you have experienced before you start to do your reporting and your visualizations. Second thing, larger organizations do have a lot of data available. We have customers with 40,000 plus data sets. Their R&D departments know about 1,300 of them. So how do you make sure that these people actually get access to knowledge about more of this data? That is the whole data cataloging, data telephone book kind of functionality, which you might automate in different stages. But the main thing is that you make available the knowledge about which data you actually have available in your organization, so that people building data visualizations and reporting have the basics to do that. And then if you know which data is available and you have some feeling for how good the data is, you want to run your algorithms on it. And your algorithm should, of course, answer your business question. Your business question being the kind of reporting, the kind of visualizations you want to build, can be influenced very much by which algorithms you use in the first place, because they answer different questions. But these algorithms also have a dependency on the input data. So the data characteristics of the input data can really basically prevent you from using some algorithms. Not in practice, the algorithms will run on your data, but the results will be false. They will not be correct because of some kind of dependencies in the data or some type of data characteristics in your input data that you didn't check close enough. This is very important. So choose the right type of analysis on your data and use that for visualization. And that is not only related to the business problem, but also to the data that you put in. The next one is then, okay, you built your reporting, you built your analysis, and you built your visualization. What kind of information are you actually sending to your receivers? Because you influence a lot what your receivers actually will think in the end. And that is a good example here with the baseline problem, the typical standard one. On the left-hand side, the baseline is changed. So it looks like the differences are bigger than they actually are, as you can see in the right side picture, if you take away the spoofing of the baseline. So this is a typical trick that people use, but the receivers are misled in this case. And we do that on a daily basis. Since Corona, we have learned how to use backgrounds in Teams. Remember the first time you saw that? It was cool. Here I am. I was not allowed to fly, so I had to go to a customer in Berlin. I took the motorcycle. And then halfway I had to have a team meeting with my colleagues. A video stream should be on. So I used a spoof background just out in the open on near farmland. And so I sent information to the receivers that I'm at work at the job. And you see it's a completely different impression you get than what reality was. And this is typical. So think a bit about it. Do you really want to do that, or doesn't it matter? Sometimes you want to do it, sometimes you don't do it, but it has a large effect, of course. And also, through which channels do I send my information in the end? I mean, the same information sent through these two channels will completely give you different expectations. So that the information, even if it's the same, will be set in a different light. You will be interpreted in different ways just by the channels you choose. So be also a bit conscious about that. If you do analysis, what kind of channels do I want to run it to? And can I make my analysis and my reporting more robust against this kind of context changes? And the last one is how your message is actually interpreted by the receiver. So in this case, you see a picture of the United States. The colors that are chosen here tell me, as a consumer, that this might be heat and cold, or it might be height, so geographical. That is where you use this kind of color schemes, typically. So the semantic mismatch here is that it is actually about religion. So where is a specific religion most outspread in the United States or not? So, but the message that is interpreted by me as a receiver is something completely different. So this is a semantic mismatch in your data visualizations that is also very important to have a look at. And then you see that you really have 6 phases in this process, like I said, and all these phases are important to have insight in and understand before you build your data visualizations. So if you look at the takeaways, there is a need for a good data ecosystem underlying your data science and data visualizations. It's a logical consequence that you must really dive into this data ecosystem and build this as robust as possible and as informative as possible, because, and that is the second point, trust and proof is important and more important and more important. We are automating more of our data ecosystem. We're automating more of the sensory inputs that we get in, that makes data streaming into our data ecosystems. There's more and more data streaming into that. We have more and more data providers that we integrate with our own data. So the trust in that this data is of the quality that we think it is, and the proof that we know it's coming from the place where we think it's coming from, and we trust these places where the data comes from, is very, very important if you're automating. So the need for good data governance and data management systems around that ecosystem are very important. And these 2 things should be underlying all your data visualization tasks. The third thing is the receiver perception. We also see, like the example with the motorcycle, with the dummy data, with the receiver and the channels that you use, that there is a larger and larger divide in the ways information are interpreted. It is a pluriform, omni-channel problem at the moment. Data visualizations and reportings are spread through the world, through many channels with different receiving publics, with different contexts and different ways of interpreting what's going on, but also the sending of the memes is completely different from, for example, the daily news with journalists make and use a lot of time on to set together. But they are received by the receivers probably as just as important and true. And this is definitely a grand divide that we see appearing here in the, how do you convey your message, how do you receive messages, and how do you build them in the correct sense.
So what is Capgemini Insights and Data? Well, it's the coolest place to be if you love data, analytics and AI. We're a global leader with over 20,000 people. Everybody is in data analytics and AI. In the Nordics, we're about 1,000 people, making us the true market leader. And we do everything in this field. We have the Activate team, which are really working on advisory services, analytics strategies, and so on. We have the data platform, data governance team, preparing all the data. We have our analytics and visualization team working with BI tools and stuff like that. And of course, we have a lot of great data scientists.
So now you know who we are. We're looking forward to 2 very nice days in the M2 track at the Data Summit in Stockholm. We have a lot of interesting companies that you want to have a look at in the next 2 days. I can just mention a few of the talks that are about AI, which is all about people and culture. We have storytelling in data. We have 50 ways to show your data, professional data visualizations. We have talks about knowledge and graphs, which is kind of a little soft spot for me, enhancing productivity with appropriate visualizations, but also visualizing your racing performance in sailing. So I really imagine that you can have a lot of fun in the next 2 days. So let's get back to Thomas. Thomas, where are you?
So
are you swimming?
Thank you so much for watching. It was a lot of fun.
Thank you, Thomas. And thank you all, of course, for listening to us. And now, enjoy.